Hello and welcome. Let's try to solve another Leetcode problem. So this is going to be a design problem, 1472, design browser history. So let's first try to understand it. So definitely the problem is going to be really easy to understand. This is our browser, it is here, and then maybe we want to visit something else. So maybe let me just maybe click yeah, I cannot click here, but definitely let's try something else. Maybe yeah, let's try this one.
Empower your students.
And then we just go back. Yeah, so this is just what we are doing. So let me just explain the problem better from here. So the browser history is similar like what we did. So currently we have a browser of one tab where you start all the home page. So now for me, I'm inside of the home page. Now it is at home page. So this is my home. And I can visit another URL, get back the history number of steps, or move forward in the history number of steps. So this means I can go forward and I can go backward. Yeah, so this is just the home directory for me. And the browser history initializes the object with the home page. Yeah. So for example, if the home page is just home, so now I have a home page. Yeah. So normally, why we are dealing with the browser history problem, normally first of all we're gonna think about a stack. Definitely we're gonna use a stack to solve the problem. Yeah. So the meaning of the stack, on top of the stack, it's gonna be the current page. So currently this home is on top of the stack, and currently we are in home page. Yeah. So this is the meaning of the browser history. Now we have a void function. It's gonna be the visit. So the visit URL gonna be visit URL from the current page. So for example, if visit home, it's gonna still be the home, but it will clear up all the forward history. So for example, we have home page and we have AB. Now we're gonna click home. What are we gonna do? We just clear up all the forward history because the forward is A and B, but we're gonna click it. We're gonna just delete it. So our browser will be just the home. If we click home, we're gonna just delete the forward history. So this is the meaning. And now it should be easier for the back and forward. So for example, back and just go back several steps, and forward just go forward several steps. So for example, we have forward 1, and it is A, so it's gonna become home and A. So if we have a backward 1, so it's gonna be just go to the home. But we need to also store the history because this is not a visit. This is just backward. While there's a backward operation, we need to, yeah, so for example, while we have a backward operation, currently we are at A. While we have a backward operation, we will go to home. Yeah, and home is on top of the stack, and we can return it immediately. But we need to record where I have already visited, but I need to record the backward the history of A, because after this operation maybe I need to do a forward. I need to get this A, otherwise I cannot get it. So for me, I'm gonna use a double edit queue to store this variable A. So for example, currently I am at the directory A, and I will click backward. So while I'm clicking this backward, I will pop this A out of the stack, on top of the stack, and then I'm gonna return this home. So definitely this will be my current URL. It is on top of the stack, but this A will be stored in another queue. It is at the head of the queue, so I'm gonna store A. Yeah, so this means for the stack I don't have this A, and for the queue I have A. Yeah. So what about the next operation? So what about the next operation? If I have a forward, so what I gonna do? I just put this. I just check this A. If my forward is 1, I just want to check how many A's do I have. So if I have an A, so I will just pop it from the queue. I will pop left, so I will pop left, pop this A out of the queue, and my stack's gonna -1, and I will put A on top of the stack. And currently, I can return this A because on top of the stack, it means my current URL, so I can return this A. But for my queue, it's gonna be empty because I did the forward operation. Yeah, so this means the queue will always store the forward history. If I click a visit, maybe visit another page, maybe C, so I will just clear up the queue because I don't need to have the forward history. So I will just clean it up, and I will just put C on top of my stack, and I'm gonna return this C as my current URL. So if you understand it as what we are doing for while we are clicking it and go to the different directories, while we can go back and go to the home page. It is exactly the same idea if you are familiar with it. So now let's just start on solving the problem. So as I said before, I'm gonna define a stack. It's gonna be the home page. So this means, yeah, we have a home page and we're gonna put it inside of the stack. It means it is the current URL, so it is defined on top of the stack. Now we're gonna prepare another variable. It's gonna be on self.queue. We're gonna define an empty queue, double-added queue. It's gonna be the forward history. Yeah, basically we need to understand everything about it because there are so many operations and it's really easy to make mistakes. Yeah, because sometimes, for example, we have a URL like A, B, and C. Currently, we are at this URL C, and what about if we have a backward operation like 10 steps? So what are we gonna do? Yeah, because for one step we go to B, another step we go to A, but we cannot be empty, so we will stay at this A. So it means this is gonna be on top of the stack. Even though there are so many operations, we just return this A. Yeah, so this is some constraints. We have to be careful with it while we are solving the problem. Yeah. Now let's just try to check this visit. So for the visit operation, if I visit a page, I just wanted to put it on top of the stack because on top of the stack it will be my current page. So I will just append it. But after append it, I need to clear the history. So the history gonna be the forward history. So what is the forward history? It is the self.queue. So self.queue gonna be equal to the queue. So similarly for here, I would to use a double-added queue for this problem. Yeah. Now let's first try to solve the back operation. So how can we solve the back? So we need to use a while tag. So while there's something inside of the stack, but I need at least have one URL inside my stack. Yeah, because according to the description, I need to have one URL. The stack can never be empty. This is also my design. I want to keep at least one URL. So the length of the self.stack should be more than 1 because I want to keep at least one URL inside my stack. And in this way, I can return the element on top of the stack directly for this back operation. So, and if the steps is more than 0, so I just need to prepare these steps. Basically, the steps means it is more than 0, but I will just delete that. This means maybe it is more clear with a 0. So if I have steps and if I have a length of the stack at least 1, definitely I can do something. I'm gonna pop out this URL from the self.stack. So after popping this URL, what I'm gonna do? After pop this URL, I want to put the URL inside a queue because I want to store the forward information. Yeah, so self.queue needed to append, but I need to append left. Yeah, because this is going to be easier for my operation because after back and forward, if I do it append left and pop left, it should be easier for me to do the operations. Yeah, so self.queue.append left going to be this URL. And finally, I need to return the self.stack because at least I have one element. So it's going to be self.stack -1. And also for the steps, it should be minus equal to 1 because I finished one operation, it's going to be a -1. Yeah. So in this way, while the step equal to 0 or the length of the stack becomes 1, I will just jump out of the while loop and I can return the current URL. It is on top of the stack. Now, similarly, I will do the forward operation. Actually, it's going to be the same. Yeah. So forward information, everything will be just inside the queue. It is not the stack because currently I am on top of the stack. If I go backward inside of the stack, it is a backward operation. But I want to do the forward operation. It means everything should be inside the self.queue. So similarly, we're going to use a while self.queue, and I have some forward steps. Yeah. So I'm going to prepare a URL. I will pop it out from the self.queue. It should be pop left. Yeah, so this means, for this ABC, so currently I am at C. If I were to do the backward operation, so this C will be stored inside the queue. Yeah, and then I have a backward operation of this B. So B will also inside the queue. B will be here, yeah, and C will be here because I always want to append at the left of the queue. So in this way, while I do a forward operation, so for example, currently I am at A. I'm do a one forward operation, I will be at B. So where is my B? It is just at the head of the queue. So I just pop left. So this is why I pop it from the left side. Yeah. So after pop it, I want to append it inside the stack. So self.stack should append this URL because I always want to return the current URL. It is on top of the stack. Yeah. So I think that's gonna be the solution for the problem. So I forget to just minus the steps operation because if I do a step, so the steps should minus equal to 1 if I did a forward did one step. Yeah. So this is gonna be the entire code. As you can see, it's not so long, but actually it is a lot of tricks. We have to be careful. First of all, we have to think about some data structure. Definitely it's going to be a stack. But one stack is not enough. We have to prepare another stack or another queue to solve the problem. For me, I think the queue is easier for this problem. So I'm going to use a double-added queue to solve it. And for every operation for the visit, so after I get the URL, I have to clean up the queue. So I have to clean it up from here. So it's going to be an empty queue. And for the back operation, I have to check if there's something inside of the stack. Definitely, I would to keep at least one element inside of the stack. And in this way, yeah, I can just return the self.stack minus 1 on top of the stack as my final return. And for the forward operation, I need to find something inside of the self.queue. If there's something, definitely I would to pop it out, and I would to put it, append it to my stack, and I'm gonna return the element on top of the stack. So the queue is also cleared a little bit, and the stack is also ended a little bit. Yeah. So this is going to be the entire solution for the problem. Let me just run it to check. As you can see, it works. Let me now submit it to check if it can pass all testing cases. As you can see, it passed all testing cases. I think the time doesn't matter. Yeah, because definitely this is going to be a ON solution. Because for each of the operation, it's going to be just O1, like the stack pop, append, and queue, append, and pop. Yeah. So maybe I can, yeah, I cannot analyze the time complexity for this one, but definitely this is going to be an ON time solution, and then this N going to be 5,000 according to 5,000 calls. So thank you for watching. See you next time.